Good afternoon. Everybody awake after lunch? So I'm right before the graveyard shift, I think. So like Bill said, Brandon Delis, currently Director of Strategic Programs. I'm sure that means a lot to everyone in the room. Essentially, what my job is we work on programmatic solutions for fleet-wide problems, if I put it in one sentence. So if you think about the last 5 to 10 years, all of my team has really been working on is environmental compliance. So that's really been the big hit for the fleet. I think as others have said this morning and this afternoon, if we look at the train wreck slide, we're to a point now where a lot of those, train wrecks have happened. A lot of the rules have been finalized. And specific to water, we've reached a couple milestones, specifically 316B, which I won't talk about, but effluent guidelines, which I'll talk about it. So when I was putting this presentation together, I thought I was like, this is actually the 4th time I've presented at this conference. I first did it back in 2013, and I talked about the latest proposed effluent guidelines. And so in our job and my team's really key to success is having what we say that sharp crystal ball. And looking out into the future and looking at what we have to comply with and making those decisions when we need to make them to ensure that we're in compliance. So I thought it'd be interesting, and I actually went back to my 2013 presentation and I plucked out the actual slides. So I promise I didn't doctor these slides. So for the first 3, I'm just going to pull out what I talked about in 2013. So if you all were here and listening to me then, I apologize. And I have to listen to me again. But this is one that I think we actually first presented this back in 2013, but we've presented it ever since because it's as true today as it was then. Essentially, the combination of the CCR rule and effluent guidelines has done a number of things to a station. So CCR really by itself is going to regulate what we do to our existing ash ponds, and if we choose to build impoundments in the future, set that criteria. And then effluent guidelines is really setting technology-based limits for things like FGD wastewater, bottom ash transport water. So when they work in combination, so that green box, you see we're really talking about ash conversions, fly ash, bottom ash, and then we're talking about facility-wide wastewater treatment. So what do I mean by that? If I can get this to advance. Again, another slide that I showed in 2013 kind of gives you a picture. It's going to be hard for me without a pointer, but essentially, if you look on the left-hand side, you've got bottom ash handling or dry bottom ash handling. So really what we showed there, I think at that time it was it going to be closed loop? Was it going to be open loop? Here we're showing it in a closed loop fashion. You've got other low volume wastes and non-chemical metal cleaning wastes that come out of your station. You have to manage that as well as landfill leachates and FGD wastewater. And then the effluent guidelines itself established a technology-based limit, or at least it gave us a number of options. As a gentleman from Mitsubishi showed us a number of options to consider, but one of those likely outcomes was biological treatment. So again, pretty close, I would say, if we were grading our crystal ball. One thing that probably changed was the metal cleaning waste, but not too much different than what we are today. I think the key thing when I talk about station level wastewater treatment, you're talking about that new retention basin that you see there. Really, you need something to deal with heavy fluctuations in process flows, polishing, things like that, and that's established through that retention basin. So this was a slide that we went over that talked about the challenges at the time. So again, totally verbatim for 2013. A lot of these are not concerns anymore. Some of them are. Just going through the ones that are still biological treatment. So if you are going to go the biological treatment route, which was explained, we have an option of going zero discharge for FGD water, but if you do, we say biological treatment. There's, today we probably call it selenium removal, because you don't necessarily have to use a biological treatment, but that is the generally accepted practice or proven technology. At that time, there was only one proven supplier. I would say today there's more than one. Some would say 5, some would say 3. We're probably in the 3-ish ballpark. There is a number of ones still developing, and I would say in the next coming years there'll probably be more. Performance, obviously, still an issue. We look at polishing technology downstream of the bioreactor, but certainly still an issue. Non-chemical metal cleaning waste, more site-specific. It wasn't necessarily tackled, not necessarily thrown out, but not necessarily tackled by effluent guidelines. Complete dry fly ash handling, I think that was a given. I think it was a given with CCR. It was a given with effluent guidelines even then, and it is today. And then dry bottom ash. Again, I think the industry fought hard against this. I think we always saw that it was going to go dry, but we were really hoping to have an open loop option where we could continue to discharge that water. I think there was a compromise with the rule where it's got to be closed loop, but if we did have to purge that system for whatever reason, we could actually use the FGD system. So again, a small win there. So again, pretty close. Just kind of wrapping up that, if I look at back in 2013, what was my regulatory uncertainty? So when I was having to put together a compliance strategy for effluent guidelines, what were the things we had to kind of guess, pick and choose at? The first one, just the ash pond closure, with CCR, it was always, is it going to be hazardous or is it going to be non-hazardous? And that was going to drive how we had to close our basins, and it was also going to drive the timeline of those. Dry bottom ash, same thing like I talked before. Was it going to be open loop? Was it going to be closed loop? Well, what were we going to have to deal with that, and what were the station-wide impacts if we did have to go closed loop? And then FGD wastewater, it was always, are we going to get a selenium limit? The industry, again, we fought very hard against that. And then, were they going to require zero liquid discharge for FGD water? So if I fast forward to today, really where we stand today, obviously CCR finalized, non-hazardous. So again, cap in place in play for closure, but obviously there are other things and other factors that drive how you close that basin. I think the biggest surprise for CCR that was not in our crystal ball was the timelines. I think I spoke last year at this conference and talked about the aggressive timelines in the CCR rule, giving 2- and 3-year closure or timelines for redirecting of ash ponds. Again, today that's still a challenge, even being a year out from some of those early deadlines. Definitely a challenge and definitely a surprise. Effluent guidelines, again, published late last year. Again, some of the key factors, zero liquid discharge for ash transport water. So that's fly ash and bottom ash. Again, it doesn't mean totally dry systems. It just means you cannot discharge the water from that system. And then a selenium limit for FGD water. One surprise that we did have in there, and it was discussed earlier today, is you have an option if you'd like to go zero discharge for FGD water. And if you take that option, you have until the end of the window, as I show in the bottom bar, you have until basically the end of 2023, so basically the end of the 5-year window to make that happen. So it kind of sets up an interesting decision point, which I'll discuss in a further slide. The last one is stricter permit limits. So I think a lot of times, and especially these conferences, we all sit here and we focus on the big federal rules, the big targets, CCR, effluent guidelines. But really, water compliance is very site-specific and very region-specific. It can be tied to the water that you're discharging to. So for us, we also have to look at what the trends are in our own states, the trends in the region, to try to understand what my permit might look like. And so for that, you really have to pay attention to a lot of what our peers are doing, a lot of what other industries are doing, because that ultimately is going to drive what a permit writer may put in your permit. So timelines with this, like I talked with the CCR, we're really looking at doing everything that you saw with the exception of the FGD treatment, all by the end of 2018. Duke will have all of that work complete to meet CCR deadlines. And then effluent guidelines, again, November 1st, 2018 is the compliance date. You can certainly ask your state permit writer for an extension, but you'll have to justify that extension beyond that. And way our states at least have been handling that is similar to Matt's, where you go to them and explain well, this is the things that I'm going to do, and this is my schedule, and ask for that additional time. And we're in the process of doing that. So if I take that same set of regulatory uncertainties, what did those final rules tell me? Where did I get to? So really, ash ponds, non-hazardous. I still think the question is, do you excavate or do you cap in place? I think it's very site-specific. It's very pond-specific, depending on disposal, how much ash you have in there. And then, of course, for us in North Carolina, we have a state law, CAMA, that also is dictating closure method, depending on risk levels. So that's still an uncertainty at this point. Dry bottom ash, I would say that's about as closed of an issue as we got. So close the loop, zero discharge. Our fleet, we're retrofitting with submerged flight conveyors. But really the last one is what I wanted to spend the rest of my time talking about. It was really FGD wastewater. And do you go the selenium removal route, continue discharging and meet those technology-based limits, or do you take the option of zero discharge, go through that process, and take the little bit of extra time? I'm sure you guys love sitting here watching me just click on this. So it's working better. I feel fortunate that they fixed it. So really, when we look beyond effluent guidelines, so to me, to answer that question today, I've got to get my crystal ball back out. I got to start looking at it and saying, what's going to happen in the future? So when you think about FGD wastewater, there's a lot of pressure on it. There's, as stated earlier this morning, limits are very, very low. But I don't think the pressure's done. There's still a lot of pressure coming from other industries. So like I stated before, you have to look at what other states are doing. You have to look what's happening within your state, within your region. And for us, we talked a lot about the positives of fracking today. One of the negatives is it's putting a lot of scrutiny on wastewater, specifically on things like boron and TDS and chlorides. So there are states that are now taking on limits and assessing plants with limits for things like TDS, boron, chlorides. For us in North Carolina, we're concerned about bromides, and I'm sure others will too. That's probably one of the next frontier as far as water quality-based limits or permit limits. So you're seeing a lot of pressure out there, and I won't stand up here and say that it's not going to happen. I won't say up here and say it will happen. I'll probably tell you that it's likely. It's just a matter of when. So when I'm trying to answer this question, well, do I go ZLD now or do I wait? It's really of when do I think that's going to happen, not if. I'd say when is it going to happen, and that's really going to drive our way to an answer. So to get into the subject, and kind of peel back the onion of zero discharge, I just wanted to talk about what ZLD is. So I don't know how many times we've heard ZLD already today. I'm sure I've heard it in presentations. I'm sure I've heard it in conversations around the room. One of the things that is commonly confused is it's a permit condition. Zero liquid discharge is I'm not discharging the water. Some people like to think that it's a technology. So sometimes it gets referred, and within Duke it happens a lot, it's commonly confused with a thermal treatment system or a VCE. To the point where our VCE system that we have at Mayo Station, we call it the ZLD system. But in reality, it's not zero liquid discharge. Really, one of the things that we don't talk about is you're concentrating a waste stream. What you get out of it is you get a brine and you get a clean waste stream. So you've got two streams now that you have to deal with. So as we say, it's like ZLD is really a minimum two-step process. But when you hear it discussed and referred to, generally people only talk about the first step, which is the concentration step. No one ever talks about the disposal step. And that disposal step is really, to me, is a big driver and certainly a big uncertainty when it comes to choosing ZLD or not at this point in time. Analogy to be used is carbon capture. So when we first talked about carbon capture, everybody had a technology. We'll use this amine solvent. We're going to capture it. No big deal. And then someone finally said, well, what are we going to do with it? It's the same thing here. You know, we've got a brine. What are we going to do with it? My luck has run out. Oh, there we go. Okay, there we go. As long as I don't hit the eject button, I'll be in good shape. So just diving into the technologies, you know, when we talk about the concentration step, I think there's a number of technologies that are out there. I would tell you that this is a rapidly developing area. Probably, I would call it tried and true, or the go-to has been the VCE, or thermal treatment system, or some people just call them ZLD systems. So that, again, has been discussed, and the gentleman from Mitsubishi covered it very well, probably better than I could. There's also ion exchange, and then there's inductive evaporation. So that's what you heard from Mitsubishi. We have a similar system, not quite a slipstream, but a similar system at our Cliffside 6 plant. Certainly viable. I would say it has its limitations. And then the last two you have, you know, are really membrane technologies. So they're the RO system. There's also a forward RO, or forward osmosis system. And if anybody wants to know how that system works, I'm going to have to draw a picture because I can't explain it in words. It's a very confusing process, but both show promise and are developing quickly. And again, the reason why there's such an influx of development, obviously with the rule, there's an incentive out there. The second is that the VCE system is very, very expensive. So I think Mitsubishi said expensive. I'd say very, very expensive. And not only is it expensive to build, it's expensive to operate. And not only is it expensive to build and operate, it's very complex to operate. And when you got FGD, which doesn't tend to be a very consistent process and a consistent waste stream, it adds another complexity that adds to the operation of this, the successful operation of the system. So I think it's fair to say that it's a last resort for a lot of folks. So you see this development of new technology and really pointing towards membranes. And I'll talk about our own experience at Duke. We actually did a membrane pilot back, I think in 2012 we did it. We had to beg RO suppliers to come and let us put FGD water in it because they were so scared it was going to scale. They were like, you can't do that. So we're to the point now where it is developing so rapidly. It is a very, very promising technology. We had a very successful pilot there. EPRI has done a number of successful pilots, bench scale and at the Water Research Center. It is definitely on its way. So that said, you're probably going back to, all right, Brandon, why aren't you jumping into the ZLD ship? Well, really, it's that disposal piece. And, you know, when I talk about the technologies, man, they're almost there. So if I look at that extra window I get by taking that incentive and wait till 2023, maybe I can jump into that. What's really making me apprehensive is that disposal piece. So one you can do is you can crystallize. So that would be like induct, or that's actually going to a crystallized salt. But you got to landfill that. And it's highly soluble. As soon as it rains, it's gone. You know, you can mix it with fly ash. That's what some folks do. So instead of going to full crystallization, you can take that brine, you can mix it with fly ash, and you can put it in a monofin. Guess what happens when it rains? Comes out again. So really, we're really looking at that last bar, that last box. What can we do, and I'll use this term, I talked about carbon capture. What can we do to sequester the contaminants in the brine in a solid product that we can landfill, and we know it's not going to leach out, it's going to stay put. So talking about solid sequestration, again, another developing area that I would credit Southern Company and the folks at EPRI for making a number of advances in the recent months, and probably the last year. We've recognized that just a crystallized solid or a fly ash wastewater or concentrated brine mix is not going to hold those constituents. you're going to see it in the leachate. It's going to come back, and it's going to come back. If it's an on-site landfill, it's going to come back to your plant. You're going to have to deal with it again. So the only way, or at least the known ways of doing it, is actually coming up with an optimum mixture or recipe. Using fly ash, some lime, some gypsum. You can also use an inhibited solid product to kind of contain that product and stop it from leaching. This is no different than what we already do at our plants in Indiana and Kentucky. The only, I would say, the technology advancements is how those mixtures are determined and how they're mixed and how they're disposed of. We've found that if you do a more rigorous mix, that you can actually bind and create a stronger product with less permeability, and thereby limiting, not eliminating, but minimizing leaching. So again, all great and good, but when we look at the whole cost principle or cost spectrum, you got a lot of impacts to operations with that. You got lost byproduct sales. So if you got a plant that sells all its gypsum, you got a plant that sells all its ash or even some of its ash, you're taking out that revenue stream, and not only that, the revenue stream's gone, but now you've got disposal costs that you have to deal with. So it's not just that revenue stream if you are lucky enough to get a revenue stream, and then the cost of disposal. So it's a double negative. On top of that is that increased landfill usage. So a lot of our facilities, they may not have an on-site landfill to deal with this. And if they do, it's not designed, or at least the strategy is not set up to handle this additional solids, because it's considering selling half of its gypsum or selling half of its ash. So you've got another increased cost to the business. And then on top of that, operational limitations. So I like to say that what you're doing with fixation is you're kind of tying the tail back to the head, in that everything that goes in and however the plant has to operate all has to fit in with that operational envelope that's tied to that recipe. So an example would be, well, what if I need a certain amount of fly ash and a certain amount of gypsum to make this mix? Well, what happens if they bring in a low ash, high sulfur coal? All of a sudden I got more gypsum than I need, and I don't got enough fly ash. So now I'm buying fly ash. So again, it's a challenge to make this work. And I would also say that it's regional because of the fuel. So when I look at this, kind of coming to an end here, when I look at this and I look at the costs, I just try to stack the costs. And this is kind of a qualitative analysis. I'd love to give you the numbers, but I get in trouble. So when I look at like total installed costs for selenium removal, operating costs, and I compare those to a ZLD, so like a VCE plus a sequestration, we're talking significant cost advantage of the selenium removal. In addition to that, the operating costs are much lower. But then you start tacking on these lost byproduct sales, landfill costs. Then on top of that, you're increasing, again, your cost of operation. And when we got coal units, like Joe mentioned earlier, you got coal units competing, especially in the Carolinas for us, competing against gas units. That margin is very thin. So if you increase the cost of operations of this coal unit even further, well, now all of a sudden this plant's not operating. Now we got fixed costs, we got units sitting there not operating. So again, another kind of cost to stack onto it. So in conclusion, when you kind of look at that qualitative analysis and you kind of try to sharpen the crystal ball, and if I put my crystal ball in word art form, this is what it would look like. Essentially, we're going down the phys-chem biological road, but we're keeping our eye very close on the development of technologies in the zero liquid discharge arena, specifically investing in time and energy and dollars directly in the development of things like membrane technologies and fixation recipes and fixation landfill methods to really try to minimize that cost in the future. And the basis for that is really what we see is that we're talking about such a significant impact, such a significant cost over and above biological treatment, that even if I had to do ZLD a few years later, I've covered my cost. And not only that, ZLD isn't necessarily a regulatory certainty at this point. Certainly, like I said before, it's going to happen. It's a matter of when. So at least at this point in time, because of those cost impacts, I really just can't take advantage. To me, that additional time to comply is not worth it to us. So with that, I'll stop and maybe take some questions, hopefully, if I have any time. No questions. You guys are, I put you to sleep, didn't I? It's going to take you some time to formulate them. I do have a round table tomorrow, so I'd love the opportunity to talk one-on-one with folks. Am I going to stand up here awkwardly?